71% of this planet is ocean, and we have mapped less of the seafloor than we have mapped the surface of Mars, so what exactly are we missing? By the end of this video you will understand why mainstream geology now takes seriously the idea that a continent-sized landmass disappeared beneath the waves within the last 12,000 years, and why that changes everything we thought we knew about ancient human history. In 2017, geologists announced that a continent called Zealandia, roughly the size of India, had been sitting completely submerged beneath the southwest Pacific Ocean for 80 million years, hiding in plain sight because 94% of it lies underwater. Scientists had known about Zealandia for decades, but they had never given it full continent status, meaning entire land masses can vanish from our mental map simply because most of their surface is wet. And here is the question that drives this entire video: if one continent could hide under the ocean for 80 million years without geologists agreeing it existed, what else is down there? Around 360 BC, the Greek philosopher Plato did something historians find deeply unusual. He described Atlantis not as allegory but as a place, with specific coordinates, specific dimensions, and a specific date of destruction. Plato wrote that Atlantis was larger than Libya and Asia combined, placed it beyond the Pillars of Hercules, the Strait of Gibraltar, and said it sank catastrophically in a single day and night around 9,000 years before his time. 9,000 years before Plato puts the event at roughly 11,500 years ago, which aligns almost precisely with the end of the last ice age and the most dramatic sea level rise in recent Earth history. At the peak of the last ice age, global sea levels were roughly 120 meters lower than today, meaning enormous areas of continental shelf that are now seabed were once dry, habitable land. The Atlantic continental shelf west of Europe and North Africa would have exposed a landmass the size of Western Europe, grasslands, rivers, and coastlines that are now 200 feet underwater. So the question is not whether large areas of the Atlantic once sat above water. They definitely did. The question is whether anything worth calling a civilization lived there before the sea swallowed it. In 1968, a pilot and a diver named J. Manson Valentine discovered something strange off the coast of North Bimini in the Bahamas, a straight-edged, apparently paved road of flat limestone blocks running perfectly east to west along the seafloor. The Bimini Road stretches for over 800 meters and consists of roughly 400 massive limestone blocks, some weighing several tons, and the debate about whether it is natural or human-made has never been fully settled. Geologists who argue it is natural point to a process called beachrock fracturing, where limestone slabs crack along natural joints in straight lines, but proponents note that the blocks are stacked in double and triple layers, something beachrock does not do. What makes Bimini genuinely puzzling is that radiocarbon dating of a micrite lens between the blocks returned an age of around 3,500 years, old enough that if it was built by a Bronze Age civilization no one has identified. But here is where the evidence takes a turn that most popular accounts completely skip. In 2009, a team using satellite-assisted sonar mapped what appeared to be a grid of right-angle streets covering an area the size of Wales off the coast of southern Spain. The team, led by researcher Richard Freund, investigated the Dinana National Park in southern Spain and found buried memorial cities inland, which they interpreted as tsunami deposits, meaning something pushed enormous waves deep into the Iberian Peninsula. Plato specifically said Atlantis was destroyed by floods and earthquakes, and southern Spain sits directly on the boundary between the Eurasian and African tectonic plates, one of the most seismically active zones in the Mediterranean region. The 1755 Lisbon earthquake, one of the most powerful in European history, registering roughly magnitude 9, sent a tsunami across the Atlantic that was felt as far away as the Caribbean, proving the region is fully capable of catastrophic, sudden coastal destruction. Here is where it gets genuinely strange. A 2023 study of the seafloor west of the Canary Islands identified a region of anomalously thick continental crust sitting on the ocean floor at depths where oceanic crust should be thin and dense. Continental crust is chemically and physically different from oceanic crust. It is lighter, more granitic, and does not belong on the deep ocean floor, so its presence there means either something submerged it or it was left behind when a continent rift apart. The Atlantic Ocean itself formed when the supercontinent Pangaea split apart roughly 200 million years ago, and as it rifted, fragments of continental crust were left scattered across what is now ocean floor like crumbs from a broken plate. Some of these fragments are called microcontinents or continental ribbons, and the Kerguelen Plateau in the southern Indian Ocean, the Seychelles Bank, and the Lord Howe Rise are all confirmed examples of sunken continental crust that once sat above sea level. The Kerguelen Plateau alone is 3 times the size of Japan, and it sank because oceanic cooling caused the seafloor beneath it to subside. The same process could theoretically have sunk Atlantic continental fragments much more recently. Now, recall the question we opened with, and here is the answer that modern science actually gives. There is no confirmed evidence of a technologically advanced civilization on any of these submerged landmasses, but the absence of evidence is not the same as evidence of absence. We have directly surveyed less than 25% of the seafloor at high enough resolution to detect human-scale structures, meaning 3/4 of the ocean bottom is still a blank, unexamined map. The technology that confirmed Zealandia as a continent, high-resolution multi-beam sonar, only became widely available in the past 2 decades, which means we are living through the first era in which systematically finding sunken structures is even physically possible. In 2013, researchers using LiDAR, a laser scanning technique originally designed to map rainforest canopies, revealed the full extent of the Khmer city of Mahendraparvata in Cambodia, a city larger than modern Phnom Penh that no one knew existed because jungle had swallowed it completely. If laser scanning can reveal a city the size of a modern capital hidden under a forest, what might high-resolution sonar reveal when we finally map every meter of the deep Atlantic? The Mid-Atlantic Ridge, a mountain range running the entire length of the Atlantic and taller than the Alps, was itself completely unknown to science until the 1950s, when Marie Tharp and Bruce Heesen mapped it from acoustic soundings, proving that entire mountain ranges can be invisible to us. Marie Tharp's first map was rejected by her supervisor as "girl talk," because the ridge she had charted precisely matched the continental fit between Africa and South America, which was still a controversial idea at the time. She had accidentally proved plate tectonics. The pattern repeats throughout ocean science. The most important features of our planet's surface were invisible to us not because they did not exist but because we had not yet built the tools to see them. So where does that leave Atlantis specifically? The honest scientific position is this: Plato's account contains enough precise geographic, geological, and temporal detail to be worth treating as a corrupted historical record rather than pure invention, but it has not been verified. What we can say with confidence is that around 11,500 years ago, a climate transition melted the ice sheets, raised sea levels by 120 meters over several thousand years, and permanently inundated millions of square kilometers of land where human ancestors had lived for tens of thousands of years. Those people did not leave written records. Their coastal settlements are now underwater, and their stories, filtered through 10,000 years of oral tradition, may have reached Plato as a memory so old it barely resembled its origin. The Dogger Bank, now a shallow fishing ground in the middle of the North Sea between Britain and Denmark, was dry land 12,000 years ago, a peninsula the size of Great Britain called Doggerland, home to Mesolithic hunter-gatherers whose tools wash up in fishing nets to this day. Doggerland was not a myth, it was not legend, it is proven, mapped, and understood, and it was an inhabited world that simply ceased to exist when the ice melted. The ocean does not announce what it has swallowed. Think about what it means that we discovered an entire continent in 2017, mapped a mountain range larger than the Alps in the 1950s, and confirmed a civilization-sized landmass in the North Sea within your lifetime, and we have still surveyed less than a quarter of the seafloor. The ocean is not a void, it is an archive, 3 kilometers deep on average, holding everything our ancestors built near coasts before the water came, waiting for instruments precise enough to read it. Every civilization in human history has understood that the sea is vast and the sky is wide and our lives are brief, and the Atlantis story, whatever its origin, carries that oldest human feeling, the terror and wonder of knowing that something enormous can simply be gone. We build things and we name them and we believe they will last, and then the ocean rises 4 inches a century, the coast retreats, and 1,000 years later no one on the surface can prove we were ever there. What Zealandia teaches us, and what Doggerland confirms, and what the submerged continental fragments of the Indian Ocean whisper, is that the shape of the world is not fixed, it is a slow argument between geology and water usually wins. And somewhere in 360 million cubic kilometers of seawater, beneath sediment and pressure and the long patience of the deep, the answer to what Plato actually remembered may still be waiting, perfectly preserved, perfectly silent, perfectly real. Follow Science Explained daily for more.